In this video, we will look at Java arrays. We'll see what we mean by a Java array, why do we need to use arrays in our program, how to declare an array and instantiate it, and later we'll see how we can access the array elements in our array. So let's start by understanding what do we mean by an array. An array in Java or any programming language is actually a collection or a sequence of variables of the same data type. And usually when we create an array, they all will represent the same type of data. So for example, if we are storing the temperature for multiple days, all my data elements in that array will represent a daily temperature. So an array is a collection of variables of the same data type. This collection could be of primitive data types like integers, doubles, booleans, or it could be even an array of objects, so a collection of the type object. Each variable in this array, we will call it an element, and each element will have an index, just like what we had with strings. So the first character in our string was at index 0 or location 0. Same thing we'll do with our arrays. The first element in our array will be at location 0, and then we also have a length for that array. So the last element in our array will be at location length minus 1. So why do we need to use arrays? Let's look at an example. Let's say that you want to store the temperature for 5 days in a week. Let's say we are storing the temperature for 5 days in a week. To store temperatures for a day, for a specific day, you will need to create a variable, and let's call it temperature1, and you will store the value of that day or the temperature in that day. So we're creating a variable in the memory called temp1, and we are storing the value which was 38 in that day, and this is the temperature in that day. Now for the second day, we also needed to create another variable, and we called it temperature2, and we are storing the value 41 in that variable. For the third day, we will need to create a new variable. We are calling it temperature3, and we are storing the value 78 in there. Same thing for day 4 and same thing for day 5. So you notice we are actually using 5 different variables to store our temperatures. Although we are storing the same type of data that represents the same information that we want to store, but we are actually creating 5 different variables to store that. Now, why is this a problem? Let's try to see that in Eclipse. So here in Eclipse, I'm going to create these variables, and let's assume that we are storing only integer temperatures, so integer temperature1, and let's assign it a value, for example, 38. Let's create another value for our temperatures. So for the second day, temperature2, let's assign the value 41, integer temperature3 equals 42, for example, integer temperature4 equals 70, and then integer temperature5 equals 80. So again, I'm storing only temperatures for 5 different days, and each one of them I had to create a different variable with a different name to store this data. Although they all start with temp, however, each one of them has a unique name. Now the problem here, if I wanted to print these temperature values, to be able to print them, I will be needing to use the system.out.println, and I need to print each temperature on its own. So temperature1, and then for temperature2, I will be needing another system.out.println to be able to print the second temperature. So temperature2, and so on. I'm just gonna copy and paste these and change the values to save some time. Temperature3, temperature4, and then the last one, system.out.println temperature5. So notice that I needed 5 different print line commands to be able to print these 5 variables. Now for now it doesn't look that bad, but imagine that you have 100 days or the full year, 365 days. In that case, you will need to create 365 different variables with different names, and you'll also need a 365 print operations, which is a lot of code. Now, you will notice we are repeating the same operation. We are just printing the temperature. So it will be very helpful if we were able to use one of the loop operations that we used in Java before, like the for loop. Now the for loop, when we did it with strings, if you remembered, we were able to use the index of the character to be able to print the character in that string. So if we had a string, for example, name, and let's store my name in there. This is the name. To be able to print the name character by character, instead of using 5 or 6 system.out.println commands, I could use a for loop starting from integer I equals 0 and I is less than the string.length, so name.length, and then I++ to go to the next character. And I only needed one system.out.println command, and I used the name.char at the index, which is I. So that allowed me to print all the characters in my name, one character at a time, just by iterating through the index, which is I, of that character. So we started with the first character at index 0, the second character at index 1, the third at index 2, 3, 4, and 5. So that's what we are trying to do with arrays. Instead of having to do 5 print lines, I can use a for loop to iterate through these items one by one using their index, and that's what we are going to do with arrays. So instead of creating 5 different variables, we'll create one collection with the variable name temp, and this collection will have all these variables in there, or all these values in there. Each value will have an index, so each one is called an element and it will have an index. Remember, we are starting the indexing from 0 up to the length -1. So we have 5 temperatures, so it's going from 0 to 4. At each index, we are storing a different value for the temperature, and that's how we will be able to iterate through these values using a for loop like we did with strings. So how do we declare arrays in Java? Arrays are considered as objects in Java. So to create an array, we need 2 steps. The first one is to actually declare a reference to that array. So this is the pointer to a location in the memory where we are going to store the array elements. And then we will instantiate the array by creating the new object. So to declare a reference, this will be our syntax. We have the data type followed by 2 square brackets that will indicate that we have a collection, not only one single element, and then the array name that you are going to give for that array. So the data type, just like we did before, integer, double, or even an object of a class. For example, if we have the class student, we want to create a collection of students. So we use student and then 2 square brackets to indicate that we have a collection now, not only a single element, and then the array name. Once you have the array reference, you can instantiate that array. So this array name will be equal to a new, followed by the same data type that you assigned for that array. So if it was an integer array, so new integer, and then in the square brackets, you will tell me how many elements you will have in that array. So this is the size, and this is an expression that will evaluate to an integer that will tell you how many elements you have in that array. So let's try to do that in Eclipse. I'm going to create an array of integers. So the first step, I want to create an integer array. So integer, the data type, 2 square brackets that will indicate we have a collection, not a single element anymore. And then we will give it the name. So let's give it the name temp. So now we have an array reference. What will this do? It will go point to a location in the memory with the pointer temp. And in this location, we are not going to store one element, we are going to store a collection of elements. Now, once we have this pointer, we will instantiate our array by telling Java how many elements we will have in that location. So we'll use the array name equals new to create a new collection, and this collection will be an array of integers. And then in the square brackets, we'll tell Java how many elements we are going to store there. So if we are going to store 5 temperatures, this is the size that we will put here. So the size, this is the number of elements we will have in that array. You can also do the whole operation in one line. So you do not have to do it in 2 separate lines. You can do the declaration and the instantiation in the same line. So instead of saying temperature in here equals to new integer, I can do it in the same line. So a new integer array with 5 elements in here. So this is how we declare and instantiate an array at the same time. So we did not assign elements yet. We are just creating a pointer to a location in the memory, and we are telling Java how many elements we will have in that location. Now that we have our array ready, we can access the array elements using the index. So to be able to access the array elements, we'll use this syntax, the array name, and then in square brackets, you will have an expression that represents the index of that element that you want to access. So this expression is going to evaluate to an integer, and this integer will be the index of the element that we want to access. The index starts from 0, so the first element is in our array is at location 0, and the last element will be the length of that array minus 1. To get the length of an array, you can use the array name dot length, and that will get you how many elements we have in that array. So remember, the length is not the last element. This is how many elements we have. The last element will be at the array name dot length minus 1. Now, the difference between the string length and the array length, in here we do not have the parentheses after the length because the length in the array is considered as a variable, an integer variable. It's not considered as a method like we have in strings. In strings, the length is considered as a method. In arrays, the length is considered as a variable or an integer variable, so we do not put the parentheses after the length in here. Now, since we did not assign any values to our array elements yet, Java will assign the default values for our elements. So if we created an array of doubles, the default value or the initial value that we'll give to our elements will be 0.0. Same thing with float, it will be 0.0. For integer, long, short, and byte, the default or initial value will be 0. The characters will be initialized to the null character, which is the Unicode 0000. The Boolean variables will be initialized to false, and then the object references will be initialized to null. So let's try to access one of the array elements that we have in here. So again, since we did not initialize or give values to our array elements yet, Java will assign them the default values. So for the integer array, the default value will be 0 for our array element. So again, to access an array element, let's actually print an array element, system.out.println. And to access an array element, we use the array name, which is in this case temp. And in square brackets, we'll put the index of the element that we want to access. Since the first element is at location 0, I'm going to print that element. So we'll put in square brackets, after the array name, we'll put the index 0, and that's the first element in our array. So if we try to run that code, it will be printing 0, which is the element at location 0. If we want to print the second element, that's at location 1, if we run it now, it will print also 0 because all my array elements will have now the value 0. Now, if we wanted to see how many elements we have in the array, we can use the dot length variable. So temp, this is the array name, dot, and then length. And you will notice it is a variable, so we did not need to put the parentheses. If you put the parentheses, you will have the red line because we do not have a method in that array called length. We only have a variable called length, which stores the number of elements we have in that array. So if we run it, since we have 5 elements, we'll get back the number 5, which is the number of elements we have in that array. So again, to access an array elements, we put the array name followed by square brackets, and in these square brackets, we'll put the index of that element. So the last element will be at the length of that array minus 1, which is 4. So if we use that, it will print the last element, which also stores the value 0 in there. Now, if we wanted to change what we stored in an array element, we can use the index of that array element to change the value. So temp at location 0, I want it to now equal to the value 35. So what will that do? We'll go to the array temperature, and at location 0, I want the value there to be equal to 35. So that will change the value we have in that array element. Let's do a change for the array element at location 1. Let's assign it the value 45, temperature 2. At location 2, we'll assign it the value 70. The temperature at location 3, we'll assign it the value 67. And then the temperature at location 4, which is the last element we have, let's assign it the value 90. So now we changed the values in our array. So we have, instead of the initial value 0 that was given to every value or every element in our array, we gave them different numbers. Now, if we want to print the array element at a specific location, system.out.println, we want to print the temperature at location, for example, 2. That's our third element. we'll go and print the value 70. So if we save this and run it, it will actually print the value 70, which is what we stored in the location 2. Now, if you want to get the last element, if you do not know how many elements you have, you can get the temperature dot length. That will get you the last, or the number of elements, but it's not the last element. To get the last element, you will have to put -1, and that will get you the last element, which is element at 4. Why? Because the length is 5. We do not have an element at location 5. The last element is at location 4. So 5 minus 1 will give you the element at location 4. So if we save this and run it, it will give me the last element value, which is 90. Now, if you already know the array elements that you will have in your array, instead of instantiating the array as an empty array and letting Java assign the initial values, if you already know the values you want to store in that array, you can actually pass these values in an initialization list. So instead of doing this, we can pass the values directly in an initialization list. In this case, you do not need the new keyword. You can pass this list in 2 curly brackets, and then these values, you'll pass them separated by commas. So 50, for example, 36, 67, 98, and let's say 45. So you'll see that we have all the elements assigned directly in here. So this is the first element at location 0, the second element at location 1, at location 2, at location 3, and at location 4. So this is what we call an initialization list. You give that list when you create the array. You initialize it directly using this list, which is comma separated values that are surrounded in curly braces. So the last element will still be at temp.length -1. So if we run this code now, it will print the value 45, which is the last element we have in that array. And again, this is what we call an initialization list. Now, an important note to remember about arrays is once you use an initialization list, you cannot re-initialize that array. So I cannot go again here and say temp and then pass another initialization list in here. So once you use an initialization list once, you will not be able to use initialize it again. So you cannot initialize the list again. In this video, we will see how we can perform operations on all our array elements. So if we want to print, for example, all the array elements, or if, for example, we wanted to read the array elements from the console where the user is inputting these array elements. So to be able to perform an operation on all the array elements, we will need to iterate through all these array elements. And the best way to do that is actually using a for loop. Our for loop header will be like we did before. We will have an initialization statement. We have an integer value, which is I, that represents the index. And we are starting from the first element, so our index will start from 0. Then we are checking, is I less than the array.length? So we do not want to exceed the number of elements we have in the array. And the last element will be the array.length -1. So if we have 5 elements, the length is 5. So the last element will be at index 4. So we are starting from element 0 up to element 4. And then after each element, when we are done with the element, we want to increment the value of I. So we want to go to the next element. So we started with element 0. After we execute the loop or do the operation we want on that element, we'll increment I, so we'll be at location 1 and so on. Now inside the for loop, we will use a reference to that element using the index I. So our array name and in square brackets will have I. So we are accessing the array at location I. So we started with I equal to 0. So the first element will be at location 0. So array at location 0. So let's look at an example here in Eclipse. Let's create an array of integers. So let's create integer and then square brackets, which represents that we have an array here, not a single element. And let's call it numbers. And this will be equal, and let's pass an initialization list. So 1, 2, 3, 4, and 5. So we have 5 elements in our array. We start with index 0. The first element is at index 0, and the last element will be at index 4. Now, to be able to print these array elements, instead of having 5 print statements, I will have a for loop that iterates through these array elements, and for each element we want to print it. So our for loop header will be starting with location 0, so I equals to 0, and while I is less than the array.length, which is called numbers dot length. We want to increment the value of I. So we started with I equals 0, the index is I, we start with 0 up to the length, and after each execution of the loop we will increment the value of I. So what do we want to do? Let's actually print these array elements. So system dot out dot print line, and we want to print the numbers at location I. So what will happen? We started with I is 0. Is 0 less than the numbers dot length? The length is 5, 0 is less than 5, so we'll be going to print the numbers at location 0, which is number 1. When we are done printing, we are incrementing the value of I, so I is now equal to 1. 1 is less than the numbers dot length, 1 is less than 5, so we'll go and print the numbers at location 1, which is this second element. We keep going until we reach the last element. After the last element, which is at location 4, if we increment I will be 5. 5 is not less than 5, so we'll not print anything outside our array. So let's execute that and run it. You will see that we are printing all the elements in our array in here. So again, any operation that I want to perform on all my array elements, I'll be using the same for header. I'm going from the first element at location 0 up to the length, not including the length, and then inside here I will access the array element using the array name and the index I in square brackets. So for example, instead of having an array already initialized here, let's create a new array using the new keyword, and this is an array of integers, and this will be 5 elements, so it will have 5 elements. And instead of printing these array elements, since we do not have array elements, I can actually read the array elements from the user. So to be able to read, I will initialize a scanner. So scanner, let's call it scan equals new scanner, and it will read from the system.n. If you did not import already the java.util, you can import the java.util.scanner and you will not have that error anymore. So what are we going to do now? We'll be asking the user in our for loop system.out.println, and we will tell them please enter an array element or an integer. If we want to display that in the same line that the user is typing in, we can use print instead of print line, and that will ask the user to print or enter a value. Now this value that the user is entering, we can access it using the scanner, so scan.nextInteger, so we are expecting them to enter an integer, so we can use scan.nextInteger. Now what do we want to do with that integer? We want to actually store it in our array. Where do we want to store it? We want to store it at the current location. So we are at location 0 when I is equal to 0. So numbers at I, we want it to be equal to the scan.nextInteger. So the value that the user is entering here will be placing it in our array. Now if you want to tell the user where they are actually in the array, you can actually have here, we can have a concatenation with I. Let's say enter an integer at the location I, so they know where exactly they are in the array. We will concatenate it with a colon, so they know where exactly they are in the array. And then the value that they are entering, we are storing it in our array. So let's try to run this code and see what happens. It's asking me, please enter an integer value at location 0. So if we entered 1, now we are going to the second location, third location, fourth, and fifth. Remember, our array starts numbering or indexing from 0, and the last location will be the length, which is in this case 5 minus 1, so the last location or last element would be at location 4. Now when I press enter, my program will terminate, and these values were stored in my array. Now if we want to display them now, we can actually display them using another for loop. So for, let's use integer, let's call it j for example, and we are starting from 0. The same header, we have j is less than the numbers.length, and then j++. Again, Since we are iterating through all the array elements, we will be using the same type of header. We're starting from 0 up to the length and then plus plus. What do you want to do? We want to print the array elements, so system.out.println, or if we wanted to print them in the same line, we can use I or the numbers at j, and then we can concatenate that with a comma. So this way we will be printing the array elements in the same line. Let's actually run this code and see what happens. So at location 0, let's add 1, 2, 3, 4, and 5. Now it's going to print it, all the array elements in this same line. Again, you can do any type of operation on your array elements as long as you are iterating through all the array elements one by one using that for loop. So instead of printing these array elements, let's say we want to calculate the total of these array elements. Since we are dealing with numbers, we can actually calculate the total. So what I can do is I can have an integer, call it total, before this for loop, and I can initialize it to the value 0. Now for each array element, I want to add that value to the total. So what I can have here, I can have total plus equals the numbers at location I. Now this actually means total equals total plus numbers at location actually j, because we are using the variable j in here. Once we have the final total after our for loop, we can print out that total. So system.out.println, and let's say your total is, and then we can concatenate that with the total. So again, we are taking the first element at location 0, the element in the array numbers at location 0, we are adding it to the total. We're going to the next element at location 1, we are adding it to the total, and so on. After we are done, so this is inside the for loop, we did not need the curly braces because we only have one statement in our for loop, but you can also add curly braces if you want to avoid any confusion. So this is the only statement in our for loop. We are getting the element at location j from 0 up to the length, not including the length, and for each member or each element in our array, we are adding that value to the total. So we started with 0, we get the first element, we add it to the total, which is 0, we get the second element, we add it to the running total, and we keep going until we reach the end of that array. And after we are done adding all the elements outside our for loop, we will be printing out the total. So we are still taking the input from the console, from the user, and then we are going to print out the total of these elements. So let's actually run this program at location 0. Let's add, have more numbers. So 10, 2, 45, 26, and let's say 70. So now we are adding these elements to the array, and after we added them, we are going to add these individual values to our total, and then we are going to print the total. So if I hit enter now, it will tell me your total is 153, which is basically adding all these array elements to the total. Another thing you can do actually, because you have the total, you can also calculate the average. Now the average will be the total divided by the number of elements. So since you already calculated the total here, you can also divide that total by the number of elements. So we can divide it by the numbers dot length, and that's the number of elements we have. However, remember, if you are dividing an integer by an integer, the result will be an integer, and that might not be accurate. So what we can do, we can cast this total into a double value, or we can actually declare it as a double from the beginning. Now, a double divided by an integer, the result will be double, and we will not be losing any values. So let's actually run this. Let's make all our array elements as different values. So 10, 12, 14, 16, and 18. So your total is, actually this is not a total, this is the average. So we can print your average is, and this is the value. Notice we have the decimal point with 0 because we are printing this out as a double value. If we want to have a decimal point, we can actually have these values in odd numbers. So let's try that. So 3, 7, 8, 9, and 19. Now notice the average is 9.2, which is a double value. If we left it as an integer divided by an integer, the value that will be displayed is 9, because we are doing an integer division where we are ignoring the decimal part of this number. So again, if you are dividing an integer by an integer, make sure that you at least cast one of them if you want to display a decimal point and an accurate result. So what we did here, we just calculated the total. The total, we started with 0. We iterated through the array elements one by one. Every time we go to an array element, we'll add it to the total, and that's how we get the total. If we want to get the average, we can divide the total by the number of elements, which is the array size numbers.length. And to make sure that we are not missing any decimal values, we needed to cast one of these values to make it a floating point number. For example, the total here was casted as a double. In this video, we will see how we can find the minimum or the maximum value in an array using a for loop. So let's say that we have this array that has 5 elements. So the first element is at location 0, and the last element will be at location 4. And this is an array of integers. At location 0 we have 38, at location 1 we have 41, location 2 78, 62, and then the last location is 80. So to find the maximum of these elements, we will need to iterate through these elements one by one and check if the element that we are in is the maximum value. So what we can do is actually we can start by assuming that the first element is actually our maximum element. We can start by that, and then we start comparing this element with the next element. If the first element is greater than the second element, in that case we'll keep that first element as our maximum. Otherwise, our maximum will be this element. We'll go to the next value and we compare them, and so on until we reach the end of this array. So the first step is actually storing the index or the location of the maximum value. So what we can do, we can create an integer here, or a variable that we will store in the maximum index, or the index of the maximum element. And since we are starting with element 0 and there are no elements before element 0, we can assume that the element or the index of the maximum element is at location 0. Now the next step is to go to the next element, which is at location 1, and we can check, is the element at location 1 greater than the element at location 0? So is this element at location 1 greater than the element at location 0, which is this element? If this element at location 1 is greater than the element at location 0, then the element or the maximum index will be at this location, which is location 1. So now, since 41 is greater than 38, my maximum element in this array so far will be at index 1. So I will change my index here. Instead of having the maximum element at index 0, now my index of the maximum element will be at location 1. We'll go now to the next element, which is at location 2. We want to check, is the element at location 2 greater than the element at the index of the maximum element? So is this element, 78, greater than the element at this index, which is 41? Since 78 is greater than 41, so the maximum element is actually now at location 2. So now we are changing the value in the variable maximum index, and my maximum element is now at location 2. We'll go to the next index, which is at location 3. We want to check the element at location 3. Is it greater than the element at this location, at location 2? Is 62 greater than 78? 62 is not greater than 78, so my maximum element is still at location 2. We did not change the maximum element index because 62 is not greater than 78, so my maximum index is still at location 2. We'll go to the next element, which is at location 4. Is the element at location 4 greater than the element at location 2? So this is my element I'm comparing with. I'm not comparing with this element. I'm comparing with the element at the maximum index. So the index of the maximum element is at location 2. So these are the two numbers I'm comparing, 80 and 78. Now, since 80 is greater than 78, so my index or the index of the maximum element will be at location 4 now, not at location 2. Since there are no more elements in my array, I know that the index of the maximum value is at location 4. So whenever I want to get the maximum value, I can go to index 4 and I'll be retrieving that. So if you look at this array, actually 80 is the greatest value we have in this array. So let's try that in Eclipse. Let's create an integer array. So int square brackets, which indicates that we have an array. And then let's name it numbers. And let's assign it a value using, or values using an initialization list. So 12, 15, or 25, 16, 78, and then let's actually put 9. Now we have our array. What we need to do now is actually have an index or a location to store the index of the maximum element. So I can call it max index, an integer called max index, and let's have this max index at location 0. So we are assuming that the index of the maximum element is the first index, or the maximum element is at the first location. Now I want to have a for loop to iterate through the remaining elements, so integer I. And now I'm not starting at location 0 because I already covered location 0. I want to start at location 1. So we are starting now with location 1. We are checking is I less than numbers.length. And then we are incrementing the value of I by 1 to go to the next element. What do we want to do for this element? So for the current element, we want to check, is it greater than the element at the max index? If it is, this is my new max. So if numbers at location I, is it greater than numbers at location max index? If it is, so my numbers at location I is the new is my new maximum. So my max index now will be I. Will be equal to I. So let's look at it again. So we started with assuming that our maximum element is at location 0. We are going from 1 up to the end of the array. If the element at location I, which is at location 1 when we start, 25, is it greater than the number at location max index? Max index is now at 0. So is 25 greater than 12? Since 25 is greater than 12, my maximum index now is equal to I, which is 1. So 1 is my new maximum index. When going back again, we are incrementing I is now 2. The numbers at location 2, which is this number, is it greater than numbers at location max index? Now my max index is not 0 anymore, it's 1. So is 16 greater than 25? It's not, so we are not executing this line. So my max index is still equal to 1, which is at this location. When we go to the next element, 78 at location 3, is 78, or the numbers at location 3, which is 78, greater than numbers at location 1, which is 25? Is 78 greater than 25? It is. So my new index is at location 3. We are going to the last element at location 4. Is the element at location 4, which is 9, greater than the number at location max index, which is 78? It's not. So my max index now is 78. So now that I have my max index, after I'm done iterating through the loop, I can print that element. So system.out.println, and we are going to print numbers at max index. So if we try to run this code now, it will be printing 78, which is the maximum number we have. So the max index is the index of the maximum number. It's not the maximum number. It's just the location of that maximum number. Same thing with the minimum. If we want to start or find the minimum value, instead of greater than in here, we can just put less than. Now less than, we are still assuming that the first element is the lowest element. And then we want to keep or check that the new element that we are at, is it less than this element at the let's call it min index. So let's change it here also to min index. So is the element at the new location, is it less than the element at location min index? If it is, we are changing the minimum index to that new location. So now if we run this, we will see that the minimum value we have is actually 9. So the minimum value is 9, which is at location 4. In this video, we will look at how we can search for an element in an array to see if this element exists in this array. And if it exists, we want to get the location or the index of that element. We will also look at how we can copy arrays. And lastly, we will see how we can compare two arrays to check if they are equal or not. So let's start with the search. What we are going to use is actually something called sequential search. A sequential search will look for a value in an array. So this value, we will call it a search key, and will determine if this value exists or is in this array. The sequential search is actually the simplest form of searching, and it's not the most efficient, but it's the easiest one to implement. So the approach we are going to do is we are checking if this element is in the array by checking element by element and comparing this element to the search key. So we start with the first element, we compare it to the search key. If they are equal, then we will return the index of that element. If they are not equal, we'll go to the next element, and we keep going until we reach the end of the array. If we reach the end of the array and we did not find the element in that array, in that case, we'll be returning -1. Why are we returning -1? Because -1 is not an index. Our indices start from 0 up to the length -1. So if we return back -1, that means we did not find the element in that array. So let's look at how we can implement this sequential search in Eclipse. So I'm going to start assuming that we have this array of integers, and I'm going to create this array directly in the class. So I'm going to make it as a static array so we can have access to it in the main method. And let's make it an integer array, 2 square brackets to indicate that this is an array, and we call it numbers. And I'll assign it values using an initialization list directly. So this is my array numbers. Now again, why did I make it static? Because inside our main method, we can only access static variables from outside this method. Now same thing, if we want to create a method here and we want to call it directly from the main method in the same class, we have to make that method also static. So let's create our search method. So I'm going to make this method public, static. And this method is going to actually return an integer. This integer will represent the location or the index of the member that we are looking for inside our array. We are going to call this method search, and this method will take an integer that represents the key. So the key is the value we are looking for in our array. So we are searching an array. This is the array we are searching, and we are searching for this key element. Now the element type will be of the same type of the array because we are looking for an integer inside an integer array. Now notice we have this red underline under the name of the method because this method is expected to return an integer and we do not have a return statement yet. So again, what are we going to return? We are going to return the location of the element key inside our array. So let's create an integer, the one that we are going to return, and let's call it the index, which is the index of the element that we are going to find. We will initialize it with -1. So if we do not find the element inside our array, we are going to return that -1 to tell the user that this element does not exist in the array. Why did we pick -1 again? Because -1 is not a valid index. So when we see -1, we know that this index is not part of our array. So we are going to return this index at the end of this method. So now we do not have this red underline. So what are we going to do now? We are going to iterate through the array elements. And to iterate through an array elements, we use a for loop. We start with 0, the first location, up to the length of that array. So the array is called numbers.length. Numbers.length. And we are going to go up to, or going one step at a time. What are we going to do for each member? So we are going at the first element. We are going to check, does this element match the key we are looking for? So if the element at location I, so numbers at I, if it's equal to the key, in that case, we are going to return I, which means that we found that element at location I. So this is the index of the element. If we did not find it, we'll go to the next element. So we're going to element 1 after that. At location 1, is it equal to the key? If it's not, we're going to the next element. We keep going until we reach that element where the numbers at that location is equal to the key. We'll return it. Otherwise, if we are done with the array and we did not get a true on this condition, we are going to return the original index, which is -1. So if we want to call this method in our main, we can call this method using the name of that method. So search, we are searching, for example, for the value 3. Now this method is going to return an integer, so we can store that integer in an integer variable. Let's call that integer actually index. If we want to print that element, so system.out.print line, we can print the element using the array name, numbers, and the index that we got from that search. Now, since we already know that element, we do not need to actually print that number. We just want to know the location of that number, so we'll just print out the index. So let's actually run this. You'll see that the element with the value 3 is actually at location 2. So this is 0, 1, and this is 2. If we look for the element, for example, 4, we are looking for the value 4 in this array. We'll get the index of that element, which is at location 3. If we try to look for an element that does not exist in our array, in this case, we'll get back -1, which indicates that this element is not part of my array. Now, let's say that we have an array that we want to copy. We do not want to make changes to the original array. We want to copy that array and make changes to that copy. So we want to maintain the original array. We want to have a backup of that array and make changes, for example, to that backup. Now, what we can do, we can try by, assigning or creating a new array. So this is the array. Let's call it Bill's backup. Let's assume we have an array called Bill's, and we want to create a Bill's backup array. So this array will have the same size. If we had 6 elements, this new array will have 6 elements. So we are creating a new double array with 6 elements. Now, if we try to do this, where Bill's backup will be equal to the cell's Bills or cell Bills, the original array, that will not be correct. Why? Because what you are actually doing here, you are not copying the array elements, you are just copying the references. Remember, this is actually a reference. This is not an object. This is just the reference. The actual data elements were not copied. We only copied the reference. So what will happen now, we have 2 pointers pointing to the same location in the memory, which is not what we want. Why will this be a problem? If you make any changes to this array, this will also affect the original array cell Bills. And that's not what we want when we copy. When we copy, we want to have each copy as an independent copy. So cell Bills will be independent from Bill backups. So we do not want them both to point to the same location in the memory. We want each one of them to have its own place in the memory. So using the equality sign or the assignment operator with the object references or the array references is not correct. What we want to do is actually copy element by element. So the new array at location I, we want it to be equal to the old array at location I, or the original array at location I. So we are iterating from element 0 up to the length -1, and for each element in the new array, we want it to be equal to the element in the old array. So whatever we had here, it will be equal to the value, or this value will be copied in this Bill's backup. So copy element by element, we are not copying the reference of the array. So let's test it here in Eclipse. Let's say that I want to make a copy of this array numbers. I'm going to create a new integer array. And let's call this array copy. And instead of assigning or copying like we had before, let's actually directly make it equal to numbers. Now we will see the problem if we make any changes to the copy or the numbers. So let's say that we want to see what we have in the array numbers system.out.println, and let's print the value at numbers at location 1. So let's run this code and see what is the value at location 1. At location 1 we have the value 2. Let's do the same with the copy. System.out.println, and let's print the copy at location 1, 2. So the numbers at location 1 we got 2, and the numbers at copy 1 we got also 2. So it appears like we copied actually the arrays. However, if we make changes to the array copy at location 1, so copy at location 1, let's make it equal to 0. So I made a change to the array copy at location 1 and I made it equal to 0. Now, since we made the change only to the copy, this change should not affect the original array, which is number. However, if you try to go and print the value system.out.println numbers at location 1, you will see it actually changed to the value that we had set in the copied array. So you'll see that we actually changed the value in the original array and in the copied array, which is not what we want. So again, when you copy an array, we do not want to have both references pointing to the same location in the memory. We actually want to copy the elements one by one. So this is not how we actually copy arrays in Java. So instead of doing this, we will create a new array. So copy will be equal to a new integer array. And let's give it the same size of the numbers array. To get the size of the numbers array, we can actually use numbers.length, which returns an integer that represents the length of that array. So both arrays now have the same size. What are we going to do? We are going to copy element by element from the original array to the copied array. So we're starting from I equals 0, the first index is 0, and I is less than numbers.length. And then we are incrementing one by one. We are going element by element in our array. What are we going to do at each element? Our copied array at location I will be copied from the original array numbers at location I. So now we have this array copied. At location 0, we are getting the array numbers at location 0. It will be placed in copy at location 0. Same thing for location 1, 2, 3, and 4. Now what will happen if we make changes to the copied array, that should not affect the array numbers. So if we run this code now, at location 2 or 1 and the numbers array we have 2. At location 1 in the copied array we have 2. If we make changes to location 1 at the copied array, the numbers array will not be affected and we still have 2 in location 1 in the numbers array. So if we run it, you'll see we still have 2 in the numbers array. If we try to print out the copied array at location 1, we will see that we have the new value, which is 0, but in the original array it did not change. So in the copied array we made it 0, but the original array was not affected by this change in the copied array. The last thing we will look at in this video is actually checking if two arrays are equal to each other. Now again, we are not checking the references, we need to check element by element. So what we are going to do, we are comparing the elements of two arrays if they are equal. We will start by checking if they have the same length. If they do not have the same length, that means they are not equal to start with. So we start by checking if they have the same size, and then we will go element by element and check if they are equal. If at any point the element in the first array is not equal to the second array or the element in the second array, we will terminate and say that this array or these arrays are not equal. So we will need to have a flag variable, a Boolean variable, to keep track if the array is equal or not. So anytime we get an element that is not equal to the element in the second array, we'll make that Boolean flag as false to indicate that we found an element that is not equal. So we'll have a for loop to iterate through the elements and then a Boolean flag to keep track if we have equal elements or not equal elements. at the end of this operation, we will check if this flag is true. If it's true, that means the two arrays are equal. If it's not true, that means the arrays are not equal. So again, we are not checking the references. If we use the equality operator, cell bills, is it equal to bills backup? That will just check if they both point to the same location. What we want to do is actually check element by element to make sure that they are equal. So let's try that in Eclipse. I'm gonna create two new arrays here. So integer array, let's call it array 1. And again, you need to have square brackets to indicate that you have an array. And let's assign it values using an initialization list. So 1, 2, 3, 4, and 5. These are my initial values. Let's create another array, integer array 2. And let's assign it also the same values, 1, 2, 3, 4, and 5. So again, we are going to compare if these two arrays are equal or not. So to do that, we will start by checking if they have the same length, if they have the same size. So if array.length or array1.length is not equal to array2.length, that means they are not equal. So if their sizes or lengths are not equal, that means they are not equal. So if we have it here, let's create our flag. So Boolean, call it is equal. And we will start by initializing it to true. So we are assuming at the beginning that these two arrays are equal. So if at any point or before we start checking, if they do not have the same size, my is equal variable is going to be false because they do not have the same size. Else, if they have the same size, we are going to check element by element. So we have a for loop for integer, and then we start by assigning this integer value I equals to 0 to start from the first element, and then while I is less than the array.length, and it doesn't matter which array, array 1 or array 2, because now we know that they have the same size, I'm going to do I++. So we're going to iterate through the elements of the array element by element. What are we going to check? We can have an if statement. If array 1 at location I is not equal to array 2 at location I, in that case, the Boolean variable is equal will be false. So that means they are not, these two arrays are not equal. So we start again with the first element at location 0. Is array 1 at location 0 equal to array 1 at location 0? If they are equal, we are not doing anything. My is equal variable will still be true. We go to the next element, we compare them, go to the next ones until we reach the end of the array. Once we reach the end of the array, we can actually print out the result. So system.out.print line, and we can actually print that is equal flag. So let's try to run this code. We have two identical arrays. Let's run that. We got true because these two arrays are equal. Let's make one of them shorter than the other. So the first one has 4 elements. The second one has 5 elements. So that means they are not equal. So when we check here, array1.length, it will not be equal to array2.length. So this variable will be equal to false. We are not executing this loop. We are just printing out false, which means that these two arrays are not equal. Let's have one element different. So the same size. We do not have a difference. They have the same size, but one of the elements is not equal to the second element or to the second array element. So we started comparing one by one. They are equal. So we're moving on. Next one until we reach the last one. They are not equal. So array 1 at location 4 is not equal to array 2 at location 4. So we set the value for is equal to be false, and then we are printing the is equal, which will be false. So if we run this, we see we are getting false. Now, if we had the first element as false or not equal, so let's say the first element here was 0, instead of iterating through all the elements, what I can do here is I can check for the size and at the same time check for the is equal. So if also is equal here. So while we have array1.length I is less than array1.length and is equal is still true, we are going to check if they are equal. If at any point we made the is equal to be false, we do not need to check the other elements, we just terminate the for loop. So when we checked here, is 0 equal to 1? It's not, so we set the value for is equal to false. Now we went and updated the value of I, so I is now equal to 1. 1 is less than the array.length, but the is equal variable is false. So this whole condition will be now equal to false. Since this condition is false, we are not going to continue with the loop, we are exiting the loop and will be running this line. So now we do not need to check all the elements, we only want to check until we reach the is equal, or we make the is equal variable equal to false. So again, we are checking element by element, we are not comparing references. So the first step, we check if they have the same size. If they do not, we make the is equal false. If they are the same size, we are going to iterate through element by element until we make one element, or find that one element is not equal to the other element, or we reach the end of the array and then we are printing out the is equal variable. In this video, we will look at how we can use arrays in user-defined classes and user-defined methods. So we'll see that how we can use arrays as instance variables, as a parameter to a method, as a return type or a return value from a method, and finally as a local variable in a method. So let's create a new class here in our package. I'm going to right click on the package and then new class, and let's call that class student. I'm going to click finish, and now we have this public class student in the same package. Now, as I mentioned before, we can use our arrays as instance variables. We can also use them as parameters to methods, or a value that is being returned from a method. So let's start with this student class. Each of our students will have a name, so let's give them a string instance variable, and we need to make that string as private to ensure encapsulation, and let's call that string name, and let's give each student an age, so private integer age, and then let's give them also a double private double, and let's name that double a GPA. So nothing new yet. We have three instance variables, a string, an integer, and a double. Each one of them is representing a different value. Let's create a getter and a setter for each one of them. So public void set name, and this will take a string name, and we are assigning the value this.name equals name. So to create a setter, like we did before, the setter is always void. It will take a value of the same data type as our instance variable, and we are storing this value name in the instance variable. We know this is the instance variable because we use the keyword this. For our getter, public, the return type will be the same type of our instance variable, string, and this one is get name, and it does not take any parameters, and we are returning back this dot name. So our getters will have a return type, which is the same type as our instance variable we are returning. They do not take instance variable, or they do not take parameters, and they will return the instance variable that we want to return. Now, let's say that we want to add a new variable or a new collection of variables that represents the individual grades for that student. Let's say that this student actually has 4 grades that we want to keep track of. Instead of creating 4 different variables, we can actually utilize arrays that we learned about before. So to create an instance variable as an array, we can still make it private. And now the data type of the array, or the data type of our grades, let's give them a double data type, and we will put square brackets which will indicate arrays, and let's call it exams. So this is our instance, a new instance variable, and this instance variable is an array of doubles. How did we know it's an array? We used these square brackets. Now remember, the square brackets, you can think of them as part of your data type. So when you are declaring your array, you will keep the square brackets with the data type of that array. Now we need to initialize this array, and we do all our initialization using our constructors. So let's actually use our constructor. I'm going to create a constructor here, public student. And this is my default constructor. My default constructor, I'm going to initialize my array, this dot exams. And I'm going to create a new double array in here with the size, let's say we are keeping track of 3 exams. So in my default constructor, I'm going to initialize the size of that array with 3 elements. So this is my size of the array, or this is the array, new double array with 3 elements. Now if I have another constructor, public student, and this constructor actually takes more than one instance variable to initialize. Let's say the name, string name, comma, integer age, comma, double GPA, and we are not taking the grades, for example, in here. In this case, I will still need to initialize my instance variable exams, which is my array variable. So to be able to do that, instead of repeating the same code that we did here, we can actually call the default constructor using the keyword this. So this keyword this, it will actually call the default constructor because we're not passing any parameters here, and this will initialize our array exams with 3 elements. So a new double array with 3 elements. Now if we did not instantiate this array or initialize it with a new array in here, if we try to access the array, we will get a null pointer exception because this reference is not pointing to anything yet. So the first step we need to do is actually point this array to a location in the memory using the new keyword and assigning a size to that array. So this is what we did in these 2 constructors. When we use the default constructor, we are assigning the or pointing this exams array to a location in the memory with 3 elements. Same thing here with this constructor. Although we are not passing the exams, we are still calling the default constructor to assign a location to that array in the memory. So we will not have the null pointer exception. We will still need to initialize the values for the other variables. So this dot name equals the name that we passed. This dot age equals age, and then this dot GPA equals GPA. So these are the 2 constructors I have. Now, as we had for the string name, we had a setter and a getter. We will have also one for the age, one for the GPA, a setter for the age, a getter for the age, a setter for the GPA, and a getter for the GPA. We will also do the same for our exams. So our exams, since they are also considered an instance variable, we will have a setter and a getter for them. So let's create the setter and the getter for the GPA, or for the exams. So I'm going to create my, first I will create the setter. So public setter will be a void. Same thing we did with regular variables. And let's call it set exams. So this will take a parameter. This parameter will be the value that we will be assigning to our exams. Now, since the exams is an array, our parameter will also be an array of the same type. So double, and we have 2 square brackets, and this is our variable exams. So we have an array. This is our parameter. We have a double array. We call it exams, and this is the value we are going to set for our exam. Now, as we mentioned before, we do not assign the values using the equality operator because we do not want to have 2 references pointing to the same location in the memory. So what we will be doing, we are actually going to copy element by element. So for integer I equals 0, I is less than exams dot length I plus plus, and then for each value that we have in this exams, we will copy it to the instance variable exams. So this dot exams at location I will be equal to the array that we passed at location I. So we are copying element by element, instead of just pointing the two pointers to the same location in the memory. So this way, nobody can change. If they try to change the values of this exams, they will have to go through the setter or the getter to access these values. They cannot access it from outside because they do not have the same pointer now. Same thing for the getter. So public, and the getter will be returning an array of doubles. So my data type of the return type will be double square brackets. So this is the return type. It's a double array. And then let's call it get exams. We are not taking any parameters. We are just returning the exams. And my return type is now a double array. So what we are going to return, we are going to return an array of the type double. So again, we do not want to return the same array. We want to return a copy of that array. So let's create an array here, double array. Let's call it copy. And this array will be equal to a new array or a new double with the same size of our exam. So this dot exams, and we want to get the length of that exam. This is inside our square brackets. So this dot exams dot length. Now we have the size of we have the copied array. We will copy the elements one by one. So for integer I equals 0, I is less than exams.length or this.exams.length. And then I++. We are going to make the copy at location I equal to this.exams at location I. And this is the array we are going to return. So after we are done, we will be returning the array copy. Notice I did not need to include any square brackets because the array is only referenced by its name. I'm not returning only one element. If you put square brackets, you will have an error because that means you are returning only one element. So if you added at location 3, you are only returning the array at location 3. But what we want to return actually is the full array. So we'll be returning the array using its name. So again, we think of the square brackets as part of our data type. So when we declare the array, we use the data type with the square brackets. If we are returning an array, we use the data type with the square brackets. If we are taking an array as a parameter, we use the data type with the square brackets to indicate that we have an array as our parameter. Now, other than the getter and the setter for these arrays, we can have any other methods that we can perform operations on this array too. For example, if we want to calculate the total of these exams, we can have a method called total that will do or calculate the total of this array elements like we did before for the total. Now let's go ahead and create an array or an object of the student class. So to create an object in the main class, we are using the class name, so student. Let's call him stu1, and this is a new student. We can use one of the constructors that we have, either the default constructor or the other constructor that takes the name followed by the age followed by the GPA. Let's actually use the second constructor. So let's create a student called Sam with the age 15 and the GPA, let's give him 3.5. So we have our student. Now we want to assign them a grade, or we want to give them the exam grades. Now the exam, if we want to give them the exam grades, we have to pass it as an array. So we can create an array here called exam. So I'm going to create a double array, double, and this is called, let's call it exams equals, and let's actually use an initialization list. So 10.5 for example, 19, and then 20. These are the grades that he got in his exams. Now we want to assign these exams for that student Sam. So what we want to do is actually use the setter to set the value of exams in student 1. So stu1 dot, and then we have set exams, and notice that the set exams will take a double array. Now to use our double array exams, the only thing we needed is actually the name of that array. We do not need to pass square brackets because we want to pass the array itself. So we use the reference to that array, which is exams. So when we call the set exams, these values will be copied to the instance variable exams one by one from the exams array that we passed in this method. If we want to get back the grades for that student, we can get back the grades using the getter, so stu1 dot get exams. So that would return a double array. So we need to store it in a double array. So this is how we can use our arrays in a user-defined class. We can use them as an instance variable. We can put them in a getter. So as the return type will be a double array, for example here, or in a setter, so that the parameter will be a double array. If we created another method, so public, and this is returning a total, which is a double value. So public double, and let's call it exam total. It's not taking any parameters. It will just use the exam array that we have. So exam total is going to return a double. So we are going to go for integer I equals 0. I is less than this dot exams dot length. This dot exams dot length. And then I plus plus. What do we want to do? We want to calculate the total. So I'm going to create an integer here, or a double here, called total, and we will initialize it to 0.0. And then for each value in our array, we want to add it to the total. So total plus equals the exam, or this dot exams at location I. So once we get the total, we will return that total. So return total. I missed the dot in here. So this dot length, and this will return the total. So if we want to print the total of the exams for that student, we can go ahead and system.out.println, and we are going to print the student exam. So student1 dot total, or exam total. So that will calculate the total for the exam. So it will add the exam total, or the exam grades that we have here, 19, 20, and 10.5. So if we run this now, we'll get the total for that student, which is 49.5. This is the total of his exam grades. In this video, we will see how we can sort our one-dimensional arrays in place using a method called selection sort. And what we mean by in place, it means we are not using another array to store the array elements. We are going to sort the arrays in the same array that we have. So for example, if we have this array that has 4 elements, at location 0 we have 17, at location 1 we have 26, at location 2 we have 5, and at location 3 we have the number 2. When we want to sort it in an ascending order, that means we will have 2 in the first location, 5 in the second, 17 in the third, and 26 at the last, fourth location, which is at index 3. So ascending sort means we are going to start with the lowest element, the smallest element, and we'll end up with the largest element, or the maximum value at the end. So how does the selection algorithm work? We start by finding the maximum element in our array. Once we find that maximum element, which is the element 26 at location 1, we want to switch that element with, or swap it with, the last element in the array. So since this is the maximum element, when we sort the array, it has to be the last element in this array. So we are going to swap the maximum element with the last element we have in the array. So if we swap them, we have 26 at the end, and 2 is going back to index 1, which is the place we had the maximum element before. Once we are done with this step, that means we have this part of the array sorted. The last element now is in place. The last element is the maximum element, and we have the remaining elements as unsorted. So since we have this part as sorted, we do not need to worry about it anymore. The only thing we need to do is to repeat the same first 2 steps on the unsorted part of that array. So once we switched the places, we had the maximum element at the end of the array. This part is already sorted. We only need to worry about this part, which is the unsorted part of that array. So we'll repeat the first 2 steps, which is finding the maximum element and swapping the maximum element with the last element. However, the last element now is not this one. The last element is the one we have in the unsorted array part. So again, the last element is now sorted, so we do not look at it. We only look at this part of this array. So we want to find the maximum element in this part. The maximum element is at location 0, which is the value 17. Then we want to do the second step, which is swapping this maximum element with the last element. Now the last element of the unsorted array is this value at location or index 2. So we want to swap that maximum element with the value at location 2. Since we have that now as sorted, so this part of the array is sorted, 17 and then 26 are in their correct locations in the sorted array, and this part is now unsorted, and that's where we will be repeating the first two steps again on this part. So 17, 26 are in their correct positions. We only need to worry about this part, which is the unsorted part. We try to find the maximum element in this part, which is element or the value 5 at location 0. We want to swap that element with the last element in this unsorted array or unsorted part of the array, which is at location 1. So we swap them. And now we have this part of the array as sorted, and we only have one element as unsorted in here. Now we want to repeat the same two steps again for the unsorted part. However, since we only have one element left, we do not need to swap anything, and that means the full array is now sorted. So how are we going to do this in Java? We will be doing the same steps again. So we will be finding the maximum element, which we know how to do now, but only for the unsorted part. So we are not going to go from 0 up to the length -1. We are going to from 0 up to the last element of the unsorted array. And we'll see how we do that in Java in a bit. The second step is to swap the elements. We want to swap the maximum value with the last element in the unsorted part of the array. So the swapping is only happening between the maximum value and the last element in the unsorted part. And then we keep repeating this operation. So we will have a for loop until we do not have any unsorted elements left. And that's when we get the sorted array. So let's see how we can find the maximum element in Java in here. So I'm going to create a method called max, and this method will return the location of that maximum element. So I'm going to create a public static, and this method will return an index, so it's returning an integer, and let's call it max. And this method will take an array, so it will take, let's assume we are sorting an integer array, so integer 2 square brackets, and let's call this array. And this is the array that we are going to find the maximum value in. However, we are not always looking for the maximum value in the full array. We are looking every time at a different size of that array. So the first time we started, for example, we started with 4 elements. The next time we will look at only 3 elements. So another value that I will pass as a parameter is actually the length, which is not the length of the array. This is the length of the unsorted part of the array. So the number of elements we are going to look at in this array. So we can start like we did before by assuming that the maximum element is at location 0. So the index, let's call it index, is actually 0. So we are starting at location 0. Now we will have a for loop to iterate through the remaining elements of the array. So integer I, we start with location 1. And then while I is less than, not the array.length, the length of the unsorted part, so this is the length that we passed, while I is less than this length, we are going to increment the value of I plus plus. What are we going to check for each element? If that element at location I, so array at location I, if it's greater than the array at location max, which is our index. So if our array at location I is greater than the current maximum value, in that case, my index or the location of the maximum element will be I. Otherwise, we will just ignore it and skip to the next value. And then when we are done with the full loop, we will be returning that index. So let's actually try this method out. Let's create in the main method, let's create an integer array. So int 2 square brackets array. And let's fill this array with an initialization list. Let's have 2, 17, 55, and 25. These are our elements. And let's call that method max, which will return the location of the maximum element. We can actually print that result, so system.out.println. and we want to find the maximum of that array. So we'll pass the array as the first parameter, and then the length of that array that we want to sort. Now, if we want to look at the full array, we have 4 elements, so we are passing 4, so that will find the maximum of these 4 elements, the location of the maximum element in this full array. So if we run this code, you'll see that the maximum element is at location 2. So 0, 1, 2, this is the maximum element, which is the value 55. Now, if we look at 3 elements, these are the 3 elements, we will still have at location 2 because 55 is the maximum value. So if we run it now, you'll see that the maximum element is at location 2. If we look at only 2 elements, the maximum of these first two elements will be actually this element, which is at location 1. So if we run this code, you'll see that the maximum value is at location 1. If we only look at 1 element, there's nothing to compare with. You'll see that we only have 1 element. So this is actually our maximum element, which is at location 0. Now we are not doing any swapping yet. So we are still getting that value 55 if we check 4 elements. If we check 3 elements, we are also getting 55 because we are not swapping. So the next step is to actually do the swapping part, which we'll look at now. So now that we are done with finding the maximum value, we want to swap the maximum value with the last location of the unsorted array. Now, swapping does not happen in one step. We cannot say that the element at location A has to go to B, and then by default, the element at location B will go to A. If we do A goes to B, the value at location B will be erased and replaced with the value A. So both locations now will have the value A, and we will lose the value that we had in location B. So to be able to do this swap, we can store this value at location B in a temporary location, or the value at location A, we can store it in a temporary location before we do the swap. So to swap elements A and B, the first step is to define a temporary variable. We can call it temp. Assign the element A to the variable temp, so we have a copy of A. And now when we put the value B into the location A will be erased from that location. However, we still have A stored in the temporary place temp. So we did not lose A, we still have a copy of A. So when we place B at the location where A was, now both these locations will have B, but we still have a copy of A stored in the temporary location. Now we will do the last step, which is getting A from that temporary location and place it in the location that we had B in. So if we look at it here, let's say that we want to swap 26 with the value 2, so the maximum value with the last location. The first step was to create a temporary integer called temp. So we are creating a place in the memory called temp. We will copy the value at location 1, which is the maximum value. So we will copy it at location 1, the value at location 1, we will store it at temp. So temp equals the value at location 1. So we'll make a copy from temp and place it, or from 26 and place it in temp. The next step, we'll move the value from location 3 and copy it, paste it in location 1. So array at location 1, the value in location 1, we want it to be equal to the value at location 3. So whatever we have here, we'll place it in here. So that will move 2 to 26, and that actually replaced 26. So you'll notice now both locations have the value 2. So if we did not copy the value 26 here, we actually lost the value 26. And that's why we needed to copy the value 26 to the temporary value. Now, since we have this copy, we will now want to place it in location 3. So array at location 3 will now equal to the value at the temp, which is the value 26. So we'll move the value 26 and place it at the location 3. So this is how we did the swapping. We created the temporary value. We copied whatever we had at location 1 to that temporary value. We copied the value we had at location 3 to place or to the location 1. And then we moved the temp to location 3, and this is how we did the swapping. So we only needed, after defining the temporary location temp, we only needed 3 steps to do this copy to not lose any values from that array. So let's go back here and do the swapping. So instead of printing the location of the maximum element, I'm going to store the location of that maximum element in an integer. So I'm going to create an integer, and let's call it max index. And I'm going to call the max method, pass the array that we created here with the length, and the length, let's give it the full array, so array.length. So now we will find the maximum element in this full array, and we are storing the index of that maximum element in this location. So now that I know this element at this location, I want to swap it with the element at the last location. So the element at the last location will be at the length -1. So this is where I will be swapping. So we said the first step is to define a temporary location. So I'm going to create a temporary integer. We'll store the value we have in that maximum location in that temporary location. So temp will be equal to the array at the max index. So we made a copy of that element, the maximum element. And then we want to copy the element at the last location and place it in the where the maximum value was in this array. So the array at the maximum index now will be equal to the array at the last location. So array at array.length -1. Remember, if you do not put -1, you will get an array out of bounds exception. Now we did the first part of the swap. We moved this element to this location. So both of them now have the value 25. Now we want to get the old value, which is 55. We want to place it here. So the array at the last location, so array at array.length -1 will be equal to the temporary value that we had stored. Let's try to print this array after we did the swap. So we can have a for loop. We start from 0. So I equals 0. I is less than the array.length. And then I ++ to increment the or go to the next element. And I'm just going to print the element. So system.out.print, and I'll print the array at location I, and then I'll leave a space between each element. So we'll concatenate it with a space. So if we run this code now, you'll see we did the swapping. Now we still have the first two elements in their same place, but the last element is now 55 and the element before that is 25, and that's what we need in here. So the next step is to repeat all this operation again, but only on these three elements. So now we have sorted the last element, and now we have these three elements. So we want to call the max method on the array, but not the full array.length. We want to go -1. So we want to decrement this by 1. We keep decrementing until we reach the 0 element. So we only have one element. So element at location 0, where we have one element. So how can we do that? We'll actually use a for loop. So when we call, instead of calling for this full array.length, we can create a for loop. So for, we start with integer I equals 0, and then I is less than the array.length, and then I ++. Now when we call this method, let's put all this code in these curly braces. So now when we call the method max, we are passing the array and not the array.length, now the array.length minus I. So the first time we start, I is equal to 0, so we're actually passing the full array. The next time it will be 1, so array.length minus 1, so it will not be 4 elements now, it will be 3. The next time -2, so it will be 2 until we reach the value length. So array.length minus array.length, we have 0 elements, and that's where we will stop. So when we run this, we also want to swap. We are not swapping with the last element -1 or the array.length -1. We also want to have -I in here, and we also want to have -I in here. So let's try to run this and see if it actually sorts our array, and you'll see it actually sorted the array 2, 17, 25, and 55. So again, we started with 0. We sort the array from the location 0 up to the length -0, which is the full array. The next time we run it, it will be -1, then -2, -3, until we reach -length. And then we are swapping. We are not swapping with the last element in the array. We are swapping with the last element of the unsorted array. So the last element of the unsorted array, the first time we run it, is the length -1. So the index 4 -0, which is this index. Then we'll go to the next value, so -1, so it will be this index. then this index, and then we will reach the last index, which is at 0. So one last improvement we will have on this for loop is to actually not execute when we only have one element left. When we have this condition, I is less than array.length, the last time we will be executing this, this for loop is when we have one element left. So I is equal to 3. So length minus 3. So if we have 4 minus 3, we have one element. So we do not need to find the maximum of one element because we know that that's the only element and that's the maximum element. So instead of going up to the array.length, we want to go to up to the array.length minus 1. So the last time we will be executing is when we have I equal to 2, which is having 2 elements left in that array.